So we are given a quadratic function, and we want to find the characteristics of that function, use it to construct a graph, and then answer questions about domain range and intervals where it's increasing and decreasing. So the first thing we need to determine is the general shape. Does it open up or open down? And since this is x squared and the coefficient is positive in front of it, we know that it opens up. So it's going to look something like that. The next question we ask ourselves, and there's no particular order here, but these are the things that we need in order to do a graph, is the vertex. That is a very important point. So let's find a vertex. And to find that, we know that the x-coordinate of the vertex is negative b over 2a. Now the a and b that are in this formula for the vertex, they represent the coefficients where a equals 1, there's nothing in front of the x squared, so that's a 1, b equals negative 6, and c equals 9. And this is the same a, b, and c that we'll use if we need the quadratic formula in order to find the x-intercepts. But right now we're looking for the x-coordinate of the vertex. So that x-coordinate will be x equals negative b, so that's negative of negative 6, and that's over 2 times a, which is 1. So that gives us positive 6 over 2, which tells us that the x-coordinate of our vertex, remember this is going to be an ordered pair, the x-coordinate of that vertex is 3. Now we need to find our y-coordinate. And in order to do that, we're going to find the value of the function. So we're going to find f of 3. We're going to put the 3 in, that is the x-coordinate, and find what y-coordinate is associated with that. So this gives us 3 squared minus 6 times 3 plus 9. We're doing substitution. 3 squared is 9. Minus 6 times 3 is minus 18. And I still have plus 9. So 9 subtract 18 plus 9 is the same as 18 subtract 18, so that's a 0. So that tells us that our vertex, there's the y-coordinate of our vertex is the point 3, 0. Other things we need to know in order to do the graph are the intercepts. So let's talk about where this crosses the x-axis, and this will be our x-intercepts. So first thing we want to try to do is factor that. So let's look for our x-intercepts. And that is x squared minus 6x plus 9 equals 0. Because an x-intercept will have y-coordinates of 0. So will this factor? Well, let's see. I'm going to try that first. And it looks like if I have x minus 3, that would give me x squared minus 3x minus 3x. That gives me my minus 6x. And negative 3 times negative 3 gives me a positive 9. So this does indeed factor. So then I take each factor and set it equal to 0. And since they're the same, I'm going to get the same value. So my x-intercept is going to be x minus 3 equals 0, or x equals positive 3 twice. My y-intercept is f of 0. So everywhere that we have an x in our original function, we put in a 0, so we have 0 squared minus 6 times 0 plus 9. And that gives us 0 minus 0 plus 9. And that gives us 9. So our x-intercept, 3, 0, which corresponds to our vertex. And our y-intercept, 0, 9. Now, we have enough information to graph this. And I'm just going to do a quick sketch here. Remember, we're just sketching these. We're not trying to plot points. So I know that it crosses the x-axis at, well, it doesn't cross, does it? 1, 2, 3, 4, 5. So it's touching there, and then it's crossing at 0, 9. So it's going to look something like that. We know that it opens up. And now that we have a graph, we're able to answer other questions about this quadratic function. The first thing is domain. So what is the domain of this function? So we're thinking about what are the possible x values. So what are the possible x values if we were looking at a shadow on the x-axis of this graph? Well, that would be all x values. So that is negative infinity to positive infinity. Now what about my range? The range is going to be a shadow on the y-axis. So if I shine the light from the side, then the shadow on the y-axis would be that going on forever. So we know that the range is going to start at y equals 0, and that is on the graph, so we use a square bracket, and then it goes on to positive infinity. The other question that we want to answer for this particular function is, where is it increasing and decreasing? So increasing is from this point going up. So if you were thinking about whether you're going uphill or downhill, it's going uphill. So it increases on the interval. And remember that your book uses square brackets for points that are the endpoints, though most math instructors will not do that. They don't include the endpoint. So this is going to be from 3 to positive infinity. And I'm going to do it the way your book does it, for increasing. And then the decreasing interval, where is it going? Downhill. Well, it starts here going downhill, so this is from negative infinity. So remember, we're always looking at the x-axis. From negative infinity, this is going downhill until it touches that x-axis. So this is negative infinity all the way to where x equals, we put a 3 in there for you, where x equals 3. And again, that's going to be included. So these are all the pieces of information that you can derive from just a function. Find if it opens up or down. One of the most critical points for a quadratic is a vertex, because remember that vertex tells you that this, if it opens this way, that is a minimum. If it opens down, then you have a maximum. So keep that in mind. The x-intercepts and the y-intercept will locate the parabola for you. You know the general shape, but in order to anchor it into the coordinate plane. And then once you have the graph, you look at your graph and determine your domain and range, and on what intervals it is increasing and decreasing. And get one last shot of everything in the slide.